Let's look at graphing piecewise functions. Now, for the purposes of this video, I am specifically working this away in order for my students to put this in the computer. However, this is still really helpful for graphing any piecewise function. So for putting it in the computer, what I want to look at first is we've got this function and we're looking at our inequalities. Both of our inequalities are relating to 2. So x is less than or equal to negative 2. Should say negative 2 there, and x greater than negative 2. That negative 2 is basically what is dividing the function. The left half is being one function and the right being the other function. That is super important when we're graphing, and so what we want to do is actually make an XY chart, a T-chart, and we're going to do that for each function, or each piece of this function, I should say. And the top of each one of these, the first x value you are choosing is negative 2 for both. I know you're like, but wait a minute, one doesn't say equal to. You're right, you are right, but we're going to figure that out and handle that situation on the graph itself. You'll see here in a second. Okay, this one is the top one. So this is for any x value less than or equal to negative 2. So I want you to pick another x value that fits that inequality. So a number that is less than negative 2 would be negative 3. Okay. The other one is the bottom function. So this one is, that's going to be, actually, let's write out the function for this first one. This first one is negative 2x minus 1. And that was, again, when x is less than or equal to negative 2. And this one is x minus 3 for x greater than negative 2. So looking at our right XY chart here, we've got negative 2. We need to figure out what another number that follows that inequality. So we're doing greater than here. And so a number that is greater than negative 2 is negative 1. And I would just go one number less and one number more for each one of those. Now, you are going to actually plug these numbers in. I, again, realize that negative 2 is not supposed to be part of the second one. That's okay. All right, so let's plug these numbers in. We've got negative 2, and we're plugging it into negative 2x minus 1. So this would be negative 2 times negative 2 minus 1. That's going to be 4 minus 1, which is 3. And then let's plug in the negative 3. We've got negative 2 times negative 3 minus 1. That's going to be 6 minus 1, which is 5. All right, let's do the same thing for the other side. We are plugging it into x minus 3 in this one. So this is going to be negative 2 minus 3. That's negative 5. And then negative 1 minus 3 is negative 4. Okay. The next thing I want you to do is we are now going to figure out what happens at negative 2 for each one of these points that have negative 2 in it for the x values. So if we look at our inequalities, x is less than or equal to negative 2. So that means at negative 2, I'm going to have a closed circle on the graph. Okay? Because of the equal to. Because of the equal to. Let's look at the other one. The other one is saying x greater than negative 2. That is not equal to. So that means that on the graph we have an open circle. And this is kind of how that open circle is how we're handling it not actually being negative 2. So we do actually need to know kind of where to put that open circle. And that is why you actually plug in there even though it's not part of the domain. All right, and now I'm going to graph this, but the order matters here. So the first thing you are going to do is graph this point, negative 2, 3. So negative 2, 3 is going to be right there. The next thing you're going to do is graph the point below that. So negative 3, 5. Negative 3, 5 is right there. The reason the order matters, normally it doesn't. If we're just graphing a line, it does not matter, okay? But the reason it matters for the purposes of graphing it in the computer is because you have some options at the bottom, and one of the options looks like this. It looks like a little ray, okay? But you've got to tell the ray which way to go. So it wants to know this point, but your other point tells it the direction of which way to point. So this is where you're starting. You're starting this one first and then this one so that it knows to start at 1 and go the direction of 2. And then it's going to go off that direction. Otherwise, if you started at 2 and went to 1, it would be going the other direction, and that's not correct because that would be going into x values greater than negative 2, and we just said you couldn't do that with the side. Okay, other things that you have. So you graphed 1 and 2, and then at the bottom, you're going to have 2 more options, a closed circle and an open circle. And so you have to actually put on the graph which one it is. So this one is a closed circle, and we wanted it to be a closed circle. So we're going to click the closed circle, and right there at that first point, you're going to put it on top. So if you just graph the points 1 and 2, right? You graph those 2 points and you don't put that circle there, it's going to count it wrong. And then you're going to be like, I graphed it correctly. Yeah, you did. It's true. But the computer wants you to take it one more step and actually tell it what happens right there. Okay? All right, so that's the left side. We now need to do the right side. So our next step would be, so that was 1, 2, and then your point was 3. Next, you're going to do 4. So that's going to be this negative 2, negative 5. So negative 2, negative 5, we're way down here. And then the next point below that, negative 1, negative 4. Negative 1, negative 4 is here. And again, that was, you have to do it in that order so that it will go that way. And then you're going to go, okay, what's going to happen here at negative 2, negative 5? So we're going to do this as step 6, click, and we need an open circle right there. Okay? So it was 1, 2, 3 for the dot, and then 1, 2, 3 for the dot, and then 4, 5, 6 for the other dot. That's a lot, I know. Okay? Basically, do you see, though, that at negative 2, don't draw this line. I'm just showing you. At negative 2 is kind of where the graph changes. So you've got to the left side is one type of graph or one type of line here. And to the right side is the other line. All right. The other 2 questions that ask on this is domain and range. So domain on a piecewise for these problems, it is always going how far left? It's going all the way to the left. Okay. So it's going to negative infinity and it's going all the way to the right to positive infinity. So the domain for these piecewise are going to be negative infinity to infinity because these 2 inequalities is encompassing the entire domain or the entire x-axis. All right. So basically I could pick any x value there and find a y value. Range, though, is going to be a little different. So again, bottom-most point. How far down does this graph go? What is the lowest y value here? So the lowest y value is that value right there. And that is the y value, negative 5. So it's going to start at negative 5. And what was happening here, I know you can't really tell, but there's actually an open circle there. There's an open circle. Remember, we put an open circle there. So if this is starting at negative 5, but we're not going to include negative 5, then that's going to be parentheses on that side. All right, and then how far up does it go? This graph continues to go on and on forever. And even though really there's like this little skip right here, that doesn't matter as long as you have points all the way up. So you do end up having, no matter where you test for the y's, you have a part of the graph there, okay? All right, so this basically is -5 right here all the way to infinity. All right? Yes, it's tricky. Let's do another one. Okay. All right. Graph this one, okay? So first step, make 2 XY charts. You know, it might be easier if you wanted to go ahead and write it up here. So x less than 1, you'd use x plus 1. And x greater than or equal to 1, you're going to use 4x minus 2. Okay, trying to make sure this was not the same problem, but it's not. And then make 2 XY charts. Okay, so how do we set this up? What is the number that is kind of dividing everything? It's 1, so that's going to go in both XY charts. Next, what is a number that should go here? And that is a number less than 1. And y'all, generally it's going to be less than first and then greater than. So this first one's going to be less than, that would be 0. And then this next one's going to be greater than, so that would be 2. Next, find the y values for each of these. Okay, so here we're plugging into x plus 1. So 1 plus 1 gives me 2, and 0 plus 1 gives me 1. This one, a little more work, we're plugging into 4x minus 2. So this would be 4 times 1 minus 2. That's 4 minus 2, which is 2. And then 4 times 2 minus 2 is 8 minus 2, which is 6. Lastly, open or closed. So this one, for 1, we do not have a line right there. So this is going to be open this time. And for this one, we do have a line. So this one's going to be the one that's closed. Now, graphing, starting off with the first point here, 1, 2, and then 0, 1. So that will go in this order. Okay, I'm going to actually erase this point because now you would still click that in the computer, but just in terms of me graphing this on here, I want to be able to actually see the hole. Okay, so next we're putting the hole there where it's supposed to be. It said this is an open circle, so we have an open circle there. But for you would click that and then click 0, 1, then go down, click the open circle, and it will fix it. Next, we're doing 1, 2. Oh, 1, 2. Wait a minute, this is the same point. That means that it is going to fill in the open circle there. So the hole that's there, we're now filling it in. And then we're doing 2, 6. So 2, 6 is up here. And that's going to go this way. Okay. Now, can this happen? Yeah, it can. Okay. It just depends on the function and the way that this is, the way the points work out. Sometimes the very point that you have that ends up or starts out as an open circle ends up being filled in by the closed circle. So even if you came here and did a closed circle here, that fills it in. So that means we really don't have any gaps here. We don't have any jumps, okay? That said, domain, I talked about this in the previous problem. This goes all the way from negative infinity to positive infinity. So that's going to be my domain because it encompasses the entire x-axis here. Range, though, this is an arrow pointing down and this is an arrow pointing down. I mean up. So this is down and this is up. So this is going negative infinity to positive infinity. So this one actually happens to be the entire domain, or sorry, not domain, range, the entire y-axis. Okay, So sometimes it works out like that. Sometimes, as you saw in the previous problem, you got it kind of going up like this. So it's not ever going to go down any further than that point. Whereas here it does continue to go down. I know these are tricky. They are for most students, and it is even trickier putting it into the computer to graph it, but I hope this helped on the order that you should be doing this. Okay?